Alrighty, let's finish off this unit with parallel and perpendicular lines. So you probably have already heard of parallel and perpendicular lines and have an idea about them, but we can look at them more closely in terms of the slope and intercept in the equation and what's the same and what's different. So parallel lines will have the same slope. So it doesn't matter whether you see the equations in slope-intercept form or point-slope form or standard form. If you find the slope of the two lines and they have the same slope, then they are going to be parallel. They could even be on top of each other, but still they're parallel because they have the same slope. And then perpendicular lines, that's another option. Perpendicular lines have a negative reciprocal slope. So what that means perpendicular lines do is that means that they cross at a right angle. And this negative reciprocal slope is a way to guarantee that. And the result of a negative reciprocal slope is that when you multiply the slope of one line by the slope of the other line and they're perpendicular, the product that you get when you multiply them together is always -1. Okay? So here's 4 different ways that you could say things are perpendicular. The word perpendicular is the same meaning as orthogonal, or normal, or right angle, or intersecting in a right angle. So you could say line A is perpendicular to line B, line A is orthogonal to line B, line A and line B are normal to each other, or they intersect at a right angle. All 4 of those mean the same thing, and a right angle, remember, is 90 degrees. So that means that they go like this, and there's a 90-degree angle right there. The way that you can say perpendicular or draw perpendicular with a symbol is an upside down T. So that symbol means perpendicular. And let's look at this negative reciprocal slope. So that means if the slope of your line was, say, like 2, then the perpendicular slope, negative and reciprocal, means you change the sign and you flip it over. So -1/2. And if you multiply these two things together, 2 times -1/2, you get -1. So if your slope was -6, the perpendicular slope would be +1/6. So again, you change the sign and you flip it over. What if your slope was -1/3? Then the perpendicular slope would be +3. And notice it goes both ways. The perpendicular to -1/3 is +3, and the perpendicular to +3 is -1/3. They go both ways. So if you take the negative reciprocal and then you do it again, you should get right back where you were. So let's draw a line in here. So y equals 2x plus 3. So we go up here to +3, and we follow the slope up 2 over 1, up 2 over 1, back, down 2, back 1, down 2, back 1. And we can draw that line in. And then the perpendicular slope of this should be -1/2, because it's the opposite. Flip it over and change the sign. So the line y equals -1/2 x plus 3 should be perpendicular. So it has the same starting point. So instead of going up 2 over 1, -1/2 means we go down 1 over 2, down 1 over 2, down 1 over 2, or up 1 backwards 2, up 1 backwards 2. And now when you look at that line right there, if I've drawn it in pretty well, you can see that this right here is a right angle. So they intersect at a perfect right angle if the slopes are the negative reciprocal of each other. Okay. Well, I've already done some example on the first one. Let's do one more example. Say we have the line y equals -1/3 x minus 4, and we want to find, draw in some lines that are perpendicular to it. So the perpendicular line, the only requirement to be perpendicular is that the slope is the negative reciprocal. So we could have y equals, perpendicular is negative reciprocal of 1/3, it would be +3. 3x plus, and I'm going to put in a b right here. B, it looks like a 6, I know, but it's a b. B could be anything. So there's an infinite number of perpendicular lines. Let's draw this first one here. Y equals -1/3 x minus 4. We go down to -4 for our starting value. Plot that point. Slope of -1/3 means down 1 over 3, down 1 over 3, and likewise up 1, backwards 3, up 1, backwards 3. So we can draw this line in here. So you can see I can draw in a lot of perpendicular lines. It just depends where I want to go. I can draw them in anywhere. And so if I choose a b value, for example, of 0, I can get y equals 3x, or I can get y equals 3x maybe minus 4, the same I had before, or I can get y equals 3x plus 3. There's a lot of different choices here. So let's draw all these and see that they're all perpendicular. So y equals 3x, I'm going to start at the origin. Slope is positive 3, so up 3 over 1, up 3 over 1, or down 3 backwards 1, down 3 backwards 1. So there's my first line. If I draw that in there, you can see it's perpendicular. Or I could do 3x minus 4. If I start here at negative 4, I can go up 3 over 1, up 3 over 1, up 3 over 1, and likewise down 3 backwards 1. So now I can draw this line in, which is also perpendicular. So there's a right angle, there's a right angle, and then 3x plus 3, if I start up here at plus 3, I can go up 3 over 1, or down 3 backwards 1, down 1, 2, 3 backwards 1, down 3 backwards 1. And you can see that this line also is perpendicular. And all three of these lines are parallel to each other. So all these lines are parallel to each other, and they're all perpendicular to this one line because they all have a slope which is the negative reciprocal, opposite sign, and flipped over from whatever this one was. So parallel and perpendicular lines, it's not too complicated, but you just have to remember to take that negative reciprocal, and that when you graph them, they should intersect in a right angle.